Hello, welcome to this presentation where we, students of Oklahoma State University, take you through this business case of predicting school dropouts and what it means in the larger picture. So before we begin, let's go through the team that has worked on this project, and all of us are grad students at Oklahoma State University, starting with Mudassir Ahmed, who is a student of electrical engineering, Daniel Contreras, myself, and Prithvi, and all of us are MIS students with some experience in data mining. So going through the agenda for the presentation, we want to know to begin with the objectives of this whole project and why do we need it and what is going to be the final outcome of it. And once we're done with that, we want to go through the methodology employed for this project, and after that we'll go through the scope of what is covered in the project and what is left out for future evaluation. Once we're done with this, we want to go through data preparation and exploration, which helped us present our models and evaluate them in a better way. And the next is modeling techniques, which were employed during the project, and results and assessment of the same. And moving forward would be the original vision versus the final product, where we try to see the differences in what we wanted to do and what we ended up doing, because that's always the learning curve. And after that is the future scope, because this analysis is evolving. We want to keep it getting better, so we'll discuss the future scope. And of course, we have learned a lot in this project, so we want to discuss how we solved the problems and finally the lessons learned. Going ahead with why this study is of importance. School dropouts is a major factor contributing to negative life outcomes, unemployment, high crime rate, and high cost to the society. So let's look at some numbers. Going by one student dropping out of high school every 26 seconds, it amounts to around 7,000 a day. And let's extrapolate that to a year. The number is over 1 million dropouts. This is a huge problem, and it is definitely worthwhile investing time in the lives of these people. Let's try and look at it in a different point of view. Let's look at a monetary value assigned to these dropouts. So some studies have found out that a typical dropout, going by just tax numbers, can cost the state around $250,000. And let's extrapolate that to an entire year's worth of dropouts. The number is mind-boggling. It's over $200 billion. So from any yardstick, this is an important issue at hand, and this study is one of the first steps towards tackling it. And who's going to be the beneficiary? Quite obviously the students themselves. It readies them for a higher lifetime earnings, because intervention done at the right time can stop them from going down the wrong path. And the next beneficiary is probably the state, because they'll have higher tax realizations owing to the better lifestyles that these dropouts can eventually have. And above all, the society at large will benefit for sure. So moving on to the methodology that has been employed in this project ahead, we adopted the cross-industry standard process for data mining, which is also widely adopted and used for such projects involving knowledge discovery. So the CRISP DM is broadly divided into 6 parts, primarily understanding the business problem at hand and the data associated with it, because once you have that, it is easy to put your focus on the real issue and not get diverted. The next step is actually the data preparation part, wherein you make your data suitable for the modeling techniques that you want to employ them with. And the next stage is the modeling itself, where you employ models that are of use to you. And finally, when we have some comparable results, we do the evaluation and match them back with the business problem. And once everything looks all good, we move ahead with the deployment. So moving forward with the methodology described, I think it's imperative that we define the scope of this investigation at the very beginning, so that our efforts are quantifiable and they are in the right direction to begin with. So the first thing that we want to consider is the demographics, because there are different kinds of people, and we don't want to explore all types of types of them, but only a few. The next thing is we want to focus on people who are users of alcohol, and the other thing we want to focus on is are the users of cigarettes. So now that we have a good grasp over the business problem at hand, let's go ahead with exploring the data and understanding more of it.
I'm Daniel, and I will be talking about the data preparation phase of this project. I will cover the five stages of the data preparation phase. On the data access and consolidation stage, we have the ICPSR consortium as our main data source, which publishes the Substance Abuse and Mental Health Data Archive every year. We use the survey for the year of 2013. We downloaded that dataset, which was on C-port format. We proceeded to convert that to a more usable SAS dataset format, and we created our target variable that is an computed value of aggregated variables such as the reason why someone left school and the age at which he or she did it. On the data reduction phase, we identify the scope of this study as the alcohol and tobacco related variables. We also identified some demographic information variables such as gender, age. Also, we had the available sex and age variables which groups the sex and age for males and females into 6 groups. We eliminated irrelevant and redundant drug usage indicators, and we further reduced the scope of the study to cigarette usage instead of tobacco usage. Then we proceeded to eliminate from the analysis the variables which were used to compute the target variable, because they were going to be structurally related to the target. On the data cleaning phase, we identified that there were some nominal variables that had too many levels, and some of them could be combined, such as when someone refused to answer a question, or when someone didn't have an answer. We coded that to 0 to reduce the levels. We merged those levels, and we proceeded to identify those values that were outside 3 plus or minus 3 standard deviations from the mean, and they were removed from the analysis. On the data transformation phase, we identified that there were some variables that presented issues with kurtosis and skewness. So we proceeded using SAS Enterprise Miner. We used the maximum normal transformation, and it gave results as a different set of transformations, such as logarithm transformation, power transformation, and exponential transformation to different variables. Using both SAS Enterprise Miner and the Tableau software, we performed a series of descriptive activities in order to do the data exploration for this project. So here we have the initial interval variable summary statistics, which show the mean, max, mean, deviation, skewness, kurtosis. Some of the skewness and kurtosis issues can be seen here. The class variable summary statistics include now the replaced nominal variables, which for those that were grouped, the levels that were grouped. And we see that the age2 variable probably has too many levels. Fortunately enough, we have the sex age group, which groups the sex age variable, which groups age and gender into 5 categories. And this variable was more used during our analysis. The distribution of the target variable dropout has more than 95 of non-events. So even if we aggregated multiple variables to create a target variable with a larger number of positive events, we still detect the need of oversampling in our study. This bar chart shows the relationship between the consumption of cigarettes in the past 30 days, the dropout target variable, and the sex age group. So we see that in all cases of the sex age group, the average usage of cigarette is larger for those that drop out from school than for those who didn't. This bubble chart shows the relationship between some of the alcohol-related variables. And here we see that those that started drinking in their teenage years have a larger average of number of days when they had more than 5 drinks in the last 30 days.
Hi, this is Prithvi, and I will be presenting on the different modeling techniques used, the results for these models, and the model that has been chosen by us as the best one. So now we will talk about the different modeling techniques that have been used in our project. The first step in model building is splitting the data into training and validation. For the purpose of our project, we have used 70% of the data as training and 30% of the data as validation. The original data that we had in the dataset contained of only 2000 observations as the dropout being 1, which is almost 3%, but the remaining 97% had the dropout being 0. If we use this data, the resulting model would become unstable. Hence, we have used oversampling. That is, we have used all the observations which have dropout as 1 and used the equal number of observations with dropout being 0. Now I will elaborate on the different modeling techniques used. The first being logistic regression, the next being polynomial regression, followed by neural network, and then decision tree. Linear regression could not be used in our modeling techniques because we have a dichotomous binary level. Hence, logistic regression is used. The target variable for logistic regression is a binary level, and the input variables that we have are categorical, binary, as well as continuous. For the purpose of logistic regression, we have used 3 kinds of selection techniques, namely forward, backward, and stepwise, of which backward is chosen as the best selection technique with the lowest validation misclassification rate. Now coming to the effects plot in the backward selection, we found that if a student being enrolled in a full-time or part-time has the highest effect on the target, followed by the next variable which indicates if a student had ever had a drink. These are the most important variables when it comes to the backward selection method in the logistic regression. Coming to polynomial regression, it is similar to logistic regression, which serves our case well, but it also indicates the two-factor interactions between the input variables. In the effects plot that we observed, we found that the interaction effects between the variables age and the time since last smoked entered the model, and the interaction effect between time since last drank and average cigarettes per day is also an interaction effect that entered the model. The overall misclassification rate of the model is 32.2%.
So coming to the neural network, we specifically fancy this model because it is capable of handling very dirty data, which is the case with us, and let's look at it. So it is usually in the form of multiple inputs. It could be categorical, continuous, binary, anything, and it particularly suits our data well because we have all of continuous variables and categorical at the same time. So the way it works is it has a hidden layer, which is essentially the neurons, which assign weights to it, and finally with the aggregated sum, which is a result of transformation, standardization, normalization of the data within the black box itself, we get a final output. And the iterations that a neural network takes, the backbone of it is the weights are being adjusted, and the neurons essentially remain the same. The only thing being adjusted with every iteration is the weights associated with them. So let's look at the results that we have. So in this iteration plot, we see that 23 iterations were taken to get the best weights for each input, and we achieved a misclassification rate of 41.5%, which is not the best, but it definitely gives us insight into how this model works. So coming to a decision tree, although it's not a typical predictive modeling tool, but it is definitely a good classification tool that we use to give some substance to our other models that were built. So let's go through how this one works. Let's pull up a pointer. So consider all of these nodes as variables, and let's go through how a decision tree would work typically. So a decision tree is essentially trying to classify the data just by looking at its outcomes. So in this case, considering this is the most important variable, which can help break down the data into these many parts, wherein the possibility of getting an event or a non-event is higher than any random sample. So in this case, we see multiple splits: 1, 2, 3, 4, or more than 2 basically. But in our case, since our target variable was dichotomous and we only had a 0-1 possibility, so we chose to restrict this to only 2 splits at every stage. And looking at the importance of the variables that this gave us, let me just clear this. So we found out that looking at the validation importance, this is scaled importance where 1 is the most important variable and not the absolutely most important variable. So part-time, full-time students, status, the sex and age, and if you have smoked 100 cigarettes at all in your lifetime, these came out to be the topmost important variables which could classify the data as a dropout or a non-dropout. This also gave us a misclassification rate of 46%, 46.7%. This was not the best we have, but it does help us give a
Now I will talk about the models that we have built and assess
look
them.
at so looking at the metrics that we have for each model, we think a validation classification misclassification rate would be the best metric for us to choose the best model, because what we're essentially trying to do is find out all possible dropouts in the future, and that is exactly what misclassification rate helps us do. So keeping a low misclassification rate will ensure that we don't miss out anybody who is going to drop out by being classified as a non-dropout, and this would cause problem of some of the dropouts not getting the proper intervention, and that is where we might fail. So we're trying to keep it at a minimum. Looking at the results we have, we got polynomial regression model as the best model with a misclassification rate of 31.8%, and closely followed by the backward regression model, which was about 39.7%. Let's talk more about these. So let's try and interpret the results that we have for polynomial regression. We found the most important factors were related to age of when cigarette use became regular, the same can be applied for alcohol, about how many alcoholic drinks were consumed in the last 1 year, and moving forward, we found that a 1 day increase of more than 5 drinks consumed in a week increases the odds of a dropout by 10.8 times, and similarly a 1 day increase of the number of drinks had in the past week increases the odds of dropout by 2.667 times.
Hi, I'm Mudassir Ahmed. I'll be discussing the original vision versus the final product of our project, scope that it holds in the future, approach adopted for the problems we face in the course of our project, and a few lessons that we all learned during the process. Let us proceed by discussing the original vision we had versus the final product. Our dataset initially had all kinds of drugs and tobacco products such as cocaine, heroin, snuff, cigars, rollover cigarettes, etc. Using all of these variables, we were planning to build a model which would start off by predicting if a person would indulge in substance abuse. Consequently, we would use this prediction as an input to another model which would predict whether a person would be a dropout or no. The design of such a model was difficult to build within our time restraints, so we reduced the scope of our project to variables involving alcohol and cigarettes, discarding all the other forms of tobacco. This change reflected in our final model, which now would bring together the variables that were related only to alcohol and cigarette, and then predict if a student would drop out from school or college depending on these observations. Let us now proceed to the scope that this project has in the future. The scope of our project can be further broadened by including all the other variables that were excluded during this project. This would help in determining a dropout, considering additional factors that might influence a person in dropping out. The data can be made available to organizations interested in creating awareness to students about substance abuse, and in turn help the students to stay away from this evil. Also, our model was designed using the dataset obtained by a survey conducted in 2013. The very same model can be implemented and used to score data for datasets obtained from surveys conducted in 2014 and so on. Lastly, if the dataset is added with additional variables targeted at understanding the psychology of a subject, this project can further help rehabilitation counselors to deal with the subjects that end up indulging in substance abuse and/or are dropouts. Let us now discuss our approach towards a few problems encountered during our project. We did not have a target variable in the dataset that was downloaded from ICPSR. Hence, we had to create one, using which, if a person dropped out of school, he was coded as 1 and a 0 if he would not drop out of school. Also, as discussed earlier, the problem of a huge scope versus time restraints was solved by excluding tobacco variables except cigarettes. Since the data we collected is survey data, there are values for people who did not respond to the survey. Such values can create all kinds of problems in model building and also lead to an unstable model. Hence, all the values for people who did not respond are grouped into one category indicated by a 0. Also, the target variable had 3% of cases for being a dropout and 97% of the cases of not being a dropout. This will lead to incorrect model estimates, and hence oversampling is required. We performed stratified sampling using all the values for dropout is equal to 1 and equal number of values for dropout is equal to 0. The models thus built had a very low misclassification rate, as low as 3%, which is not the case in the real world scenario. Hence, we had to correct for oversampling and use prior probabilities to set the initial percentages of zeros and ones in the dataset. This led to getting the correct parameter estimates. Finally, some of the variables available in the dataset had high skewness and kurtosis values. Hence, we used max normal transformation to identify the correct transformation method and used it on the variables, such as log, power, exponential. The variables after transformation had lowered skewness and kurtosis values. Let us now discuss the lessons learned during the process of our project. We were able to comprehend the overall negative impact that substance abuse had on the society and the individual. We also realized that the primary objective of the project may be subject to change during the course of the project. We figured out that data preparation has high importance in the CRISP-DM methodology and that good domain knowledge and business understanding is essential for the success of a project. Thank you for watching this presentation and feel free to get in touch with us for any questions you have.